Hey everybody, welcome back to another fun and exciting Algebra 2 class. Today we are going to be talking about frequency and probability. That is in chapter 11. We are almost there, only 2 chapters left. Keep working hard. This is on page number 494. Probability and frequency distribution. What is probability? Well, probability is the likelihood that something will occur. Also, it's called frequency distribution. In other words, how frequently will something happen? Okay, so let's go ahead and look in your book and talk about these different things. So we need to turn over to page 495. Page 495. All right, so if we want to find out how frequently or what are the chances or what's the probability something is going to occur, we need to use this formula right here. The number of desired outcomes over the number of total possible outcomes. Okay? It sounds harder than it is. All right, so let's look at it. 8 marbles are hidden in a bag. There are 4 red marbles, 3 blue marbles, and 1 yellow marble. What is the probability of selecting a blue marble? Well, let's look at our frequency distribution here, and what we need to do is take the total number of desired outcomes. What is our desired outcome? What are we looking to have happen? A blue marble. We want to pick a blue marble out of the bag. So that is the desired. How many blue marbles are there? Well, there's 3. So when we reach our hand into the bag, we have 3 possible good outcomes. If we pick a red one or if we pick a yellow one, that's not what we're looking for, okay? So we're looking for a blue marble to come out of the bag. So the total number of desired outcomes is 3 over the total number of possible outcomes. Well, we could pick out a red one, and there's 4 red ones. We could pick out a blue one. There's 3 blue ones. Or we could pick out a yellow one. So there are 8 total marbles in the bag. So 3 over 8 is our probability of picking out a blue marble. Now, I'm okay with you leaving it as a fraction. There's really 3 ways to write probability. So this is as a ratio or as a fraction. You could also write it by actually going in and dividing it out. Hopefully you don't need to divide that one out, but if you do, you can. So come over to your calculator and do 3 divided by 8 equals 0.375. So 0.375 is another way to write it. I don't love either one of those. So, this is the better way to me. Decimal, I just don't love it, and the book uses decimal a lot. It's fine. There's nothing wrong with it. It's just not typically the way you hear it. This is the way that you're going to hear it, is moving the decimal 2 places, and so that would be a 37.5% or 37.5%. This is the way you hear it said most of the time in percent. A 3 to 8, yeah, you might hear it 3 to 8. You're going to hear this a lot. Almost never do you hear it like this, but this is the way that the book puts it a lot of times. So I don't care how you write it, to be honest. They're all the same. You're in Algebra 2. Come on, you know that. You know that writing it as a percent, as a decimal, or as a fraction are all ways to express the same number. So write it however you want to, unless the book or the test asks you specifically, write it as a fraction, write it as a decimal, write it as a percent, okay? So if it doesn't ask, then you can write it however you want. Validity. What is validity? Well, validity means the truth or the possibilities. What if something is valid, that means that it can happen. If something is invalid, then it can't happen. So the chances that something is going to happen is 100%. So I put my hand into the bag to pull out a marble, And if the only thing in there is marbles, if I pull, I mean, I'm pulling out something. And if all that's in there is marbles, I'm going to pull out a marble. So there is a 100% chance that I'm pulling out a marble. Now, every single event, something is going to happen. Like, let's talk about rain. Is it going to rain tomorrow? Well, I don't know. Maybe, maybe not. But a 100% chance is there's going to be a day tomorrow that it's either going to be rainy or sunny. Now, of course, the Lord could come back and, we could be raptured up and there'd be no day tomorrow. But in the case that there is a day tomorrow, we're assuming that there is a day tomorrow because there's a 100% chance that the sun will rise tomorrow. That's what happens. So it will either be sunny or it will be rainy. I guess it could be cloudy or something like that, but the sun will come up tomorrow. That's a guaranteed. That is something that happens every single day. So there's a 100% chance of something happening tomorrow. There's going to be weather tomorrow. Okay? Every single thing. Like if I toss a penny in the air and flip it heads or tails, there's a 100% chance that it's going to land on the head or on the tail. I guess theoretically it could land on the edge. I've never seen it happen in my whole life. I guess it could happen. There could be some, weird thing that happened and it could stand on the edge. So maybe, but there's a 100% chance that it's going to be a head or a tail. So if your events don't add up to 100, then they're not valid. Now, when I say 100, it could also be 1. It could be, decimal. If you go back to this, if it's percent, it's going to add up to 100%. If it's a fraction or a decimal, it's going to add up to 1. Okay, so here we go. Validity. Let's see. Is this valid or is this invalid? Well, we just need to add them up. 0.2, 0.5, and 0.3. Just add them up, and what do we get? We get 1.0. So that is valid. That could happen. Okay, 20% chance, 50% chance, and 30% chance. Let's look at this one. In this one, we have a 2 over 5, a 3 over 5, and a 6 over 5. Add those up, and we get 11 over 5. What in the world? That can't happen because that would be more than 100%. So this is invalid. It has to add up to 1. Okay. Now, what could make this valid? How could we make this valid? Well, we could get rid of this one. We could get rid of that choice. Look what happens here. 2 plus 3 equals 5 over 5. Is 5 over 5 valid? Yes, it is. Okay. Because it's 1. So that is a valid potential event. All right. Let's look down here at the next section. The complement of an event is the chances that the desired event doesn't happen. Okay, so let's say that there's a 20% chance that it rains tomorrow. What is the complement? There's only 2 chances. Either it's going to rain or it's not going to rain. And you can't have both. You can't have like, oh, it kind of rained. No, it either rains or it doesn't rain. And I guess there's sprinkles and different things, but it either rained today or it didn't rain today. Those are the 2 chances. So what is the other chance? Notice that this is the complement. What is its complement? So if each thing has to add up to 100, what is the complement of 20? So in other words, we subtract 100 and we get 80%. So this one would be 0.8 if we're using the decimal. 0.8. That would have a 0.8 chance of not happening. So 0.2% or 20% it rains, 80% it doesn't rain. Compound events. What are compound events? Events that have multiple outcome possibilities. Okay? So in other words, I say, so I go back, let's go back to the marble thing. For example, if it could be a blue or a red marble. So I put my hand in the bag and I say, I want you to pull out a blue or a red marble. So now I've given multiple opportunities. I've said it could be either one of those. That's what's called a compound event. In other words, it's not two events. It's one event. It's just pulling out one marble. But it's a compound probability because it could be blue or it could be red. This is the key word right here. You got to focus this word right there. Or. Okay? When you see the word or, it's a compound event because you could do this or you could do this. Either one is acceptable. Okay? There's two different kinds of compound events. There's mutually exclusive and not mutually exclusive. So let's talk about mutually exclusive first. If the event from the first outcome make the desired events of the second outcome impossible, for example, go back to the marbles. If all the marbles are solid colors, you cannot pull out a red and blue marble because you're only pulling out one. So if they're solid colors, it's either red or blue. You can't pull out a red and blue. It's not possible. So in other words, you can't pull out a combined color. All right. Mutually exclusive events. This is their little formula right here. P, which is probability, of the A event or the B event. So we have two events going on. So this is the probability of the A, red, or B, blue. So this is what we're trying to find out. Here's the way that you do it. You take the probability of the A event and you add the probability of the B event. So let's look at this. Here's our bag containing our marbles. We have 12 total marbles. So we're going to take our probability of A. What is A? So it says red marble. So we'll call this the A event, or a yellow marble. So we'll call this the B event, A or B. Okay, so what are the chances that A happens? Well, there's 12 marbles, and there are 8 red ones. So we have 8 over 12 plus the B event. What's the B event? 1 yellow over 12 equals, and this is easy because you're almost always in. Now, there is a type of probability that this is going to change, but in this probability, our denominator is going to stay the same. And so it's 8 plus 1, and so it's 9 over 12. That's our probability. Change it into a decimal if you want. Leave it as a fraction if you want. So the key word there is or. Okay? That means that either one of them could happen, and then we just add them together. Mutually exclusive, add them together. Non-mutually exclusive. All right, so now what's happening is the events can occur at the same time. For example, what if our marbles were not solid colored? For instance, they were blue and red, like mixed. You've seen marbles that have different coloring on them. So now we're dealing with white and gray, or black and red, or blue and yellow. We're dealing with combined colors. So now you could pull out a marble that is both red and blue, for example. Why? Because it has both colors on it. So this is what's called non-mutually exclusive. In other words, the first one doesn't restrict the second one. They could both happen at the same time. The way that we do this is when our probability for A or B and so this is the same, probability A or B. If we go back here, probability A or B, it's the same. Mutually exclusive and non-mutually exclusive is the same right there. What's different is this, when it's non-mutually exclusive, so when there's like multiple colors, when there's combined colors where you could get both, here's what you do. You take A, probability of A plus probability of B. So it's the same thing, except we have to add something. Then we have to subtract the probability of A and B both occurring. Okay, what's that look like? So the bag of marbles has now 18 marbles in it. 5 marbles are brown and white. So look, they have both colors on them. 6 marbles are gray and white, 3 marbles are red, and 4 marbles are black and gray. What are the chances of pulling out a marble with gray or white? All right, well, that just got complicated, right? If you're wondering where I am, if you want to follow along with me, I haven't really said the page number for a minute, so let me go back. We're on page 500 right now, example 11.1. I changed it from horses to marbles just so we could keep the marbles the same all the way through, but the example does say that it's horses. But anyways, that's fine. So what we need to do right now is we need to go to this right here, and we need to say, okay, this is A event. A event equals gray, and the B event is white. Okay, so those are the two events that we're talking about. So this is the A, gray is going to be A, and here's the B, that's going to be white. Okay, so now what we need to do is we need to go through and we need to start listing out what are our chances of these two things separately. So what are the chances of a gray marble? Well, let's talk about which ones have gray. Well, the 5, they don't have gray. That's brown and white. The 6 are gray and white. So there's 6. So 6 are gray and white. And 3 are red. So those don't count. And these ones are black and gray. So there's 4. So our chances of this are 6 plus 4. Or how many total gray marbles are there? There's 10 gray marbles. At least there's 10 with some part of gray in them. Okay? So 10. How many white ones are there? Well, we have this one, that's 5. So it's 5 plus this one also has white, so 6. And that one's red, and this one's black and gray. So there we go. So white equals 11. So there's 11 white marbles in there and 10 gray marbles in there. Okay? So now what we need to do is we need to get our A and B and add them together, and then we're going to subtract the probability of A and B both happening. So let's do the first part first. So the probability of A, there's 18 total marbles, so that would be 10 over 18, and there's 11 white, so that's 11 over 18. Now we need to add those together, and this is going to be the first part. I'll move up here and do it up here so you can stay with the formula here. So let's just do it underneath of it, actually. So 10 plus 18, 10 over 18, sorry, plus 11 over 18. Okay, so that's going to equal what? And this is interesting because this is where it's like, wait, what? It's 21 over 18. And you're thinking right now, we don't even have that many chances. You're right. And that's why we have to subtract this out. What are we subtracting from it now? Now we're subtracting the ones that are A and B both. Okay? So what are we subtracting? Look at this group of marbles right here. 6 marbles are gray and white. That's what we're subtracting out. That's the A and B. So A was gray, B was white. We're subtracting out the ones that are both A and B. So let's come back up here. So 21 over 18 minus, remember this is over 18 again, right? Because that's our total number. And how many are gray and white? 6 of them are gray and white. So we'd say 21 minus 6, and that's going to be 15 over 18. So there is our probability. Now, don't leave it like this. One thing that drives me crazy and drives almost every math teacher that I know crazy is when students leave their fractions not reduced. It's fine to leave an improper fraction, but you always reduce your fractions, always. So look, we can pull out the common 3 there. We can divide each by 3, so that's going to give us 5. We divide by 3 there, and that's going to give us 6. So the correct ratio here is 5 over 6. If you're going to leave it as a fraction, always reduce your fractions. I will mark those wrong if you don't reduce your fractions. So you know better than that. So 5 over 6, okay? All right. And amazingly enough, that's all I have for you. It's kind of a long lesson, lots packed in there. But if you missed anything, review it. Try some of those practice problems. You're going to need to try those. You're going to need to practice this. Use those little formulas that I taught you and work hard to try to understand this. All right? We'll see you later. Have a good one. Bye bye.